Okay, so in this video, let's talk about Auger Electron Spectroscopy, or simply we can say AES. Now, if you remember in our previous video, we have talked about the XPS, right? We have talked about the XPS. There are some similarities between the XPS and AES, and also there are some huge differences between these two techniques. I will put the link here for the XPS if you are wondering about particular technique. In this video, let's talk about this Auger Electron Spectroscopy, like principle, applications, and how to analyze the particular data. Now, let me go through with the principle first, right? Principle is relatively easy compared to the XPS. Now, let's say we have a sample, right? Here we have a sample. What we are going to do is we are going to send high energetic electrons. Right, we are going to send high energy electrons, and we are going to bombard this electron into the surface of our sample. Now, in our sample, there are some sort of element like carbon, platinum, lead. There are some kind of elements. So, if I take a particular element, there are electrons in different energy levels. So, there are 2 electrons here, 2 electrons here. Let's say this is S and this is H state, like 1s, 2s, 2p. Likewise, okay, so there are electrons in different energy levels. Now what happens is, when our high energetic electron, okay, this is the high energetic electron, this electron comes and hit one of the electrons in the low occupancy level, this particular electron, so let me denote it as number 1. This number 1 electron will pop out from its place in the energy level, because this high energetic electron will contribute some energy towards this electron. When this electron gains some energy, it cannot maintain its position on the 1s level. It has to go out. So it will go out from the atom, or maybe from this occupancy level. Now what happens is, there's an occupancy, like there's a vacancy in this position, right? This electron has released. So there is no electron in this place. So there is a vacancy in this position. What happens is, one of the electrons in this outer level, let's say in this 2p, let's say this electron, I will denote it as number 2. This electron will come down here to fill this vacancy. Now if you remember, like if you get the concept correctly about these electrons energy levels, you know, this electron cannot come directly into this place and fill the gap, because this electron has a specific energy value. With this energy value, it cannot occupy the 1s level. This electron, this number 2 electron, has a specific energy value. It is related to the 2p level, right? If this electron has to come here and occupy this particular position, it has to leave some energy and then occupy the 1s level, because it has to release some energy in order to come here. Otherwise, it cannot come here. So what happens is, this electron, let me take a blue color. Okay, this electron will contribute some of its energy towards the neighboring electron, right? And then it will come down here to occupy the vacant position. Now look at this electron. I will denote it as number 3. Okay, this electron is number 3. Now there's a position, there's a problem here, because originally this electron has a specific energy value and it has occupied with the 2p level. But now it has gained some another energy. It has gained more energy. So now it cannot remain in the 2p level. So from this energy, this electron will pop out from the atom and it will be released out. It will release. So this is the electron we call as Auger electron. Right? This is the Auger electron which we are referring to. So from our instrument, we will catch these Auger electrons, right? We will catch these electrons and calculate its energy and put some spectra. So this is the principle, right? So you may be wondering, when it comes to the XPS, if you remember correctly about the XPS, yeah, I have the same notes here. Here, look at this. In the XPS, in the XPS, you have X-rays and then electrons popping out. You catch those electrons. But in this case, there's a a complicated process, right? Because some electron is popping out, then another electron comes down. The particular electron is contributing energy to the neighboring electron, and now the neighboring electron is the one going out. So there are 3 electrons here, 1, 2, 3 electrons involving in our process. But in XPS, if you remember, there's only 2 electrons, like particularly 1 electron, right? Only the X-rays comes down. X-ray is the energy source in the XPS. It comes down, hit an electron, the electron will pop out. So why this kind of complicated process? Because if you see this very carefully, you will see that our energy of this Auger electron here, this electron, the Auger electron, right? The energy of this Auger electron is independent from the energy source. So it has no effect from the energy source. The energy source only doing is the popping out a lower level electron. We don't mind about this electron. Only matter is this electron. When this electron comes down, this is the one which contributes its energy towards the neighboring one. So the contributing energy is not dependent on your energy source. So you can either use high energetical electron, or also you can use X-rays too, based on your preference. So that's the major advantage we have in AES. But if you remember about the XPS, right? I will put the link here again, right? So if you are wondering about the XPS is very important. So like if you are thinking about the XPS, right? The X-ray source is the one which is going to pop out the electron. So your energy of an electron is directly proportional to your energy source. That's a big thing. Okay, now there's a small nomination, right? We use some symbols to represent the Auger process. Okay, let's try to understand it. Okay, here look at this. You know about the energy levels, right? So normally in our energy levels we say here this is the K level, L level, and this is another L level. Like K is referring to 1s, L1 is referring to 2s, L2 is referring to 2p. Likewise, I hope you are familiar with this, right? Normally K is the 1s level, right? There are L1 and there is L2. So there's L2 and L3, and there is M1, M2, M3, M4 and M5, right? So L1 means that you have 2s, L2 means you are in the 2p level, right? If you remember, if you have watched our XPS video also, you will remember that 2p has two types of electrons. One is pluses, another one is minuses, right? L pluses and L minuses. If you have no idea about this L, S, this kind of thing, don't worry about it. Like these are basic quantum representations of electrons, but I think you are familiar with these L and S because these surface analytical techniques are a little bit advanced when it comes to your degree programs. So these are very basic. So in your first years maybe you have to cover these things up. So I hope you are okay with this. So L3 is also referring to the 2p. M1, M2, these are means 3p levels, right? So M1 means 3s and then 3p, L plus 1, L plus 2, likewise. These things going on, right? So there are these nominations. Okay, now what we can say is, if you remember, we have 3 electrons or otherwise 3 energy levels involved in our process. One thing you have to mention when you refer into a particular Auger process is what is the level of the electron initially popped out, which means here energy level of electron number 1. Initially when you give high energetic electron, and you have to pop out one of the electrons in the lower energy levels. So what's that energy level? You have to first state that, and secondly you have to say what's the energy level of electron number 2, the electron which comes down to occupy that particular vacancy. And finally you have to say what's the energy level of electron number 3. So in this case you will see 1s means K, 2s means L1, and 2p means L2. Yeah, L2. It can be L2 or L3. Now in this particular scenario, this Auger process can be represented as K, L, L. K is the one which initially popped out. Here, the number 1 electron is on the K level. L is the electron where 1 electron comes down, and then again L comes out as the Auger electron. This is the energy level for the Auger electron. So likewise, there are different kind of Auger processes, like let's say KLL, which is most common, and then you have LMM, and then you have MNN, then you have NOO, which this means your initial electron which comes out from our energy source is on the L state, L energy level, and then both of the other electrons which come down to occupy the created vacancy and also the Auger electron, both are on the M level, right? And then here we have the M level electron which comes out first, and then both electrons which comes down, and the Auger electron both has in the N level, right? So these kind of representations are there. Normally the KLL, this means very low atomic levels, like 3 to 14 atomic levels, like carbon, nitrogen. These kind of elements are following this particular Auger process, while LMM particularly in middle range, let's say 14 to 40. This is the atomic level, right? Atomic number. So MNN means like 40 to 79 basically. From this state onwards, we have the heavy metals, heavy elements, right? Lead, like those heavy kind of elements follows this kind of like external, like they have high energy levels to have this Auger process. So get the idea, right? So what I want you to do is get the idea about it. So if you are, let's say in your exam you are given this representation and you are asked to identify what this each level means, right? Each symbol means. The K means the energy state of the initial electron which popped out from your energy source, and then L means the energy state of the electron which comes down to occupy the vacant, and then finally the third one means the energy level of the Auger electron. That's the thing what you need to understand. So we call this notation, right? We call this notation as X-ray notation. We call this as X-ray notation if you want. Now as our final step, let's talk about the data interpretation, right? Normally just like in XPS, you will have a same kind of graph here like this. There are some peaks, but only difference is instead of binding energy you will see the kinetic energy, or otherwise let's say electron energy. So what happens is, if you remember in our XPS, right? So let me erase this. Okay, here when we have the sample, when we put the X-rays in our XPS, right? In XPS, the X-rays will pop out some electrons. So our instrument will catch these electrons. Okay, our instrument will catch this electron, and instrument will calculate the kinetic energy of your electron, or otherwise the electron's energy. Based on this energy, it will recalculate the binding energy. So your initial graph, your spectrum, will be on the binding energy. But in this case, in Auger process, right? Let me erase this one also. In Auger process, your instrument calculates directly the electron energy, right? When this Auger electron comes out, your instrument will catch it and determine the energy of the particular electron. So that energy is being represented on your graph. So this is electron energy, not the binding energy, right? If you want the binding energy, you have to recalculate it. you have to recalculate it if you want the binding energy. So in this case, you will have the electron energy. Now, if, let me ask you a specific question, right? What will happen, right? What will happen in Auger process, in Auger, this AES process? Let me use this one also. If your surface become more positive, right? So this is a peak for a particular electron. Let's say in this side you have the electron energy, which means in this direction your electron energy increases, right? Now what will happen if your surface becomes more positive, right? What will happen in the Auger process? Now you need to understand what would be the effect to our Auger electron, right, by becoming the surface positive. When surface becomes more positive, you will see that negatively charged electron will have more attraction to the surface. So this electron will sense more energy to the surface, so it will have to spend some more energy to the surface because the surface is positively charged. It need to overcome the positive charge also. So the instrument can catch this electron with low energy, right? It has also spent some sort of energy to the positively charged surface. So in this case, this is the original peak we have. But if we have a positively charged one, if we have positively charged surface, then you will have relatively low energy. Right? You will have relatively lower energy. But in the XPS, that's the opposite, right? Because XPS, you will be given the straightly binding energy. So I'm not going to talk about that also, because we have talked about in our previous video about the XPS. So for now, I will focus on our AES. So now I hope you get the idea, right? So when your surface becomes more positive, right, it will affect your electron, it will affect your Auger electron. So Auger electron will feel more attraction to the surface. So it will have to spend more energy on the surface in order to release. So your instrument will catch the Auger electron with relatively low energy. But this is the original one. This is the original peak. In this case, the original peak where the no surface positively charge is formed, right? No surface charge is formed. So our electron has to spend more extra energy for the surface. But in this case, when the surface is positively charged, your electron has to spend some more energy to the surface in order to release. I hope you get the idea, right? So that's all with the Auger electron process. And in our next video, we will talk about the depth profiling, and also there are some few techniques which we need to talk about in this surface analytical playlist. So if you have any questions, feel free to comment below. I will try my best to answer those questions. So we will meet on the next video.